Assalamualaikum. Hi, my name is Abdullah Azam bin Asmi, and me and my group will be talking about uh, pharmacokinetics, drug absorption. So let's begin. Mechanism of drug absorption is how the drug travels across cell membrane. First type is the passive or simple diffusion. This is where the drug will travel from a region of high concentration to a region of low concentration. It requires no carrier, not saturable, shows low structural specificity, and is the most used method. Liquid soluble drug will travel across aqueous pore, while lipid soluble drug will travel across membrane lipid bilayer. This facilitated diffusion, where a large molecule will travel across a cell membrane by using carrier protein that is located at the plasma membrane, and this method will require no energy, can be saturable, and also it may induce competitive inhibition. Active diffusion is where the molecule will travel from region of low concentration to a high concentration. It's about this. It will require also a carrier protein and will require energy for this method. It may become saturable and will induce competitive inhibition. The last method of absorption is called pinocytosis, which is a form of endocytosis, where it will involve the absorption of fluid or particles following their encapsulation by a cell. The membrane of the cell closes around the pharmacological substance and fuses to form a complete vesicle, which later detaches and moves into the inside of the cell. This process will also require energy to occur.
I'm Vilashni Tamarin, and I will be presenting the factors affecting drug absorption. There are two main factors affecting drug absorption, which are drug-related and body-related. As for the drug-related factor, it is divided into the physicochemical properties of drug and dosage form characteristic and pharmaceutical ingredients. The physicochemical properties of drug factors are the drug solubility and dissolution rate, particle size and effective surface area, polymorphism and amorphism, the salt form of the drug along with the ionization state, the drug pKa and pH with the lipophilicity. The following factors affected by the dosage form, characteristics and pharmaceutical ingredients are the disintegration time, manufacturing variables, nature and type of dosage form, along with the product age and storage with the pharmaceutical ingredients. The next main factor is the body-related drug absorption affected by the area of absorptive surface, vascularity, disease state, GI's pH and the presence of other substances, along with the GI mobility and the functional integrity of the absorptive surface.
Hi, my name is Paul Eileen and I will explain about the bioavailability of drugs in pharmacokinetics. Bioavailability refers to the extent a substance or drug becomes completely available to its intended biological destination. The route of administration and the dose of a drug have a significant impact on both the rate and extent of bioavailability. For a drug with relatively low bioavailability, a larger dose is required to reach the minimum effective concentration threshold. The bioavailability of a drug can be influenced by both intrinsic and extrinsic variables. Intrinsically, a drug's bioavailability can be affected by the drug's required metabolic steps to activation, the specificity of its target receptors, the patient's unique physiology, route of administration of the drug, and site of drug absorption. Extrinsic variables affecting drug bioavailability include interaction with concurrent food or substance metabolic processes and drug interactions with medication. The bioavailability of intravenous is 100%. Intramuscular and subcutaneous have 75% bioavailability. Oral administration has the lowest bioavailability, which is 5%.
Hi, I'm Mahalishmi Balachandran and will be brief on transport of drugs. The drugs are transported across the membrane by either passive diffusion or filtration. For the passive diffusion, the drug crossing the membrane to the direction of concentration gradient from high to low. The membrane does not play any part of this. Besides that, the lipid-soluble drug can go through the membrane easily because the matrix of the membrane also made up of lipids. In that case, the more the lipid solubility drugs diffuse more quickly and attains a high concentration. Filtration allows the drugs to passing through the pores. Now, depending on the requirement of energy, there are two types which are facilitated diffusion and active transport. Facilitated diffusion means transport taking place passively without needing energy. It takes the drugs from higher concentration to lower concentration, whereas for active transport requires energy. It transports the drugs against its concentration gradient from low concentration to high concentration. This active transport means for own body to metabolize. After the transportation process took place in the membrane, movement of drugs from its sites administration drugs does not have to cross biological membrane.